for sustainability. From there, he went on to spend 2 years leading and engineering through the development of cutting-edge scanning technology products for aerospace and consumer electronics. Jeremy's current efforts in GM Foods and Amazon subsidiary center on the effort to develop a means of autonomous transportation that will reduce accidents and improve overall road safety. Jeremy continues to give back to the community by volunteering at robotic STEM events and mentoring at local events with the hope that he can inspire and motivate next generation of engineers just as he was. I invite you to listen attentively Dr. Jeremy Roberts because he will be on Zoom. But before he comes to us, our mental exercise choir will come forward and bless our hearts with that song. And hereafter, we will listen to Dr.
Going to forego the song and bring on Mr. Roberts.
Okay, so Jeremy Roberts will come now and the song will follow. Thank you.
This is like as a live stream on this means it's throughout. Okay. So it's
All right. Hello. Good morning, everyone. I think that we still have need to mute sometimes. Online. All right. We have still a little bit of background noise. All right. Good morning, everyone. I hope everyone can hear me. If those in the chat can just raise their hand and say yes. All right, great. Well, first of all, I'd like to thank Mrs. Foster, Mrs. Smith, Dr. Quarry, my father, Dr. Owen Roberts, my mother, Sheila Roberts, and Victor Dixon High School for this opportunity to speak with all of you. So let me go ahead and share my screen. Okay. So I've spent most of my career working on various forms of automation from a software, systems, and operations standpoint. Today, I'll speak with you about a few projects I've worked on and hopefully inspire you to continue or start your pursuit of a STEM or STEAM career and higher education. So when you think of automation or robotics, what comes to mind? Is it this? How about these? The field of robotics and automation is growing at a rapid pace, and you can now find examples and opportunities in almost every industry. The skills needed are just as varied. Everything from software and mechanical engineering to electronics, welding, legal, and graphic design. During my career, I've had the opportunity to work in a few of these areas, and we're going to take a quick look at two of them today. Semiconductor manufacturing. Semiconductor manufacturing is a sequence of chemical photolithography, measurement, and inspection steps designed to make electronic circuits, chips, memory, and it's using a semiconductor material, with silicon being the most common. These silicon wafers are very thin, and not that big. They range anywhere from 100 millimeters up to 450 millimeters, and only 750 microns thick. These wafers are produced and manufactured in a semiconductor fab. Each of these fabs has thousands of automated machines using robots to create millions of wafers per year. And each of these wafers house several hundred chips. On the left there, you can see I actually started my career in the semiconductor industry, and pictured there's an inspection tool that I helped design and build that detects chemical non-uniformities on the surface of a wafer using a novel non-contact capacitive sensor that was developed at the Georgia Institute of Technology. Let's take a look at the anatomy of a semiconductor inspection tool. The two major components of a semiconductor inspection tool are the equipment front-end module, or EFEM, and the inspection module. At the top, contained in the box with the front-facing grates, there's a filter and a fan. These clean the air prior to entering the tool and create a laminar airflow from top to bottom, reducing particles that could cause defects on the wafer surface. Custom software is developed to control the system, provide system status, visualize the results, and allow for identifying and handling errors that might occur. Let's start at the front of the system. We have load ports designed to accept carriers of wafers, both automated and manually. There are different types of carriers depending on the size of the wafer and whether the wafers are for testing or manufacturing. Shown here is a FOUP, a front opening unified pod, which holds approximately 25 wafers. If you take a closer look at the load port, they contain several features to aid with automatically aligning, leveling, and opening the sealed carriers. You can see the alignment and leveling pins on the base, and the vacuum cups and latches to unlock and remove the door. Just inside the door are sensors that scan the carrier to count and determine the positions of the wafers inside. This information is communicated via the EFEM control software to the wafer handling robot. Wafer handling robots, they come in many different configurations and sizes to accommodate different grip types, size of the wafer, and how fast you actually want to transfer these. One example that you can see there is an edge grip robot with 2 end effectors so that they can actually pick and place very quickly. And that's mounted on a linear rail to access more than one carrier at a time. These pick and place locations are taught and stored, and after the system's been leveled and calibrated. One of these stored locations is the inspection module. For this particular inspection tool, when the wafer enters the inspection module, it is placed on the lift mechanism above the wafer chuck. The wafer is then lowered down slowly as vacuum is applied across the chuck surface. The X, Y, and Z axes move to position the sensor assembly above the wafer surface at a height where data can be collected. The chuck is spun up to speed approximately 1,000 RPM, and scans of the wafer are taken using both the laser height sensor and capacitive sensor to collect millions of data points for subsequent analysis. Taking a closer look at the sensor assembly, the height sensor calculates the relative height from the wafer surface by bouncing a laser off the surface at an angle and capturing the reflection using a combination of a lens and internal sensor. The distance is measured based on time of flight, the time in which the emitted laser beam returns to the sensor after hitting the target. The height at which the capacitive sensor needs to be above the wafer surface is approximately 50 microns. The Z-axis shown in the previous slide can roughly position the sensor in place. However, in order to precisely position the sensor, the software uses the data collected from the height sensor to determine how much further down it must move. The piezoelectric actuator is sent an electrical signal proportional to the expected move, which it then converts directly into linear motion with extremely high resolution, and this can at times be sub-nanometer. Zooming back out, this inspection process occurs over and over again as new carriers are delivered automatically, picked up and moved to the next station until all processes for the chip are completed, And you can see there on the right side, if you look at the top, that you can see is the overhead transport system. That's communicated by the tool via an infrared link. And that tells it, hey, when are you actually aligned? When can you actually drop that carrier down onto my load port? And when am I retracted and ready for you to actually go ahead and load and proceed with the process that I just went through. So that's what I had on the semiconductor industry at a very high level. But now I want to jump into something that I'm currently doing, from the beginning of my career to where I am today. And I'm currently working at a company called Zoox, which is a subsidiary of Amazon. At Zoox, we are working to create autonomous mobility from the ground up. Before we jump in and take a look at some of the technology behind what we are doing, it's an equally important, and I might argue more important, to identify and understand the why. All right. There are approximately 1.4 million fatalities per year globally due to crashes. How do we make things safer? Vehicles are used on average only 4% of the time. How do we reduce waste? How do we reduce congestion, air pollution? The why keeps me motivated to help find solutions to these questions. At Zoox, we're doing that by developing a fully autonomous, purpose-built vehicle for mobility as a service. Let's take a quick look into one of the two big aspects that go into designing this vehicle. First of all, the software. In order to develop an autonomous vehicle, it's very important to understand the world around it. And what's going on, what are its surroundings? Mapping and localization is a big part of this. And I'm going to play a video for you now. Hopefully you are able to hear that. Please ping me on the chat if for some reason you're not able to hear the video, and I'll quickly remedy that.
Before navigating through the world. Zoox does this using sensors, maps,
All right, no,
and advanced
I
software
heard someone
that
saying no
handles
sound,
perception,
so let me pause.
prediction.
One moment here. We're going to try to see if this fixes it. All right, let's try this one more time.
Have you ever wondered how Zoox is able to drive autonomously? Just like human drivers, autonomous vehicles need to be able to see and understand their surroundings before navigating through the world. Zoox does this using sensors, maps, and advanced software that handles perception, prediction, planning, and controls. Humans rely on eyesight to see, but Zoox uses a state-of-the-art combination of camera, radar, and LiDAR situated on all four corners of the vehicle. Cameras detect color, which enables the vehicle to understand things such as the state of traffic lights. Radar bounces radio waves off surfaces to detect the distance, size, and speed of objects. LiDAR fires millions of laser signals per second, which reflect off objects and return to the vehicle, creating a highly accurate 3D model of the surroundings. Combined, these sensors create a 360-degree overlapping field of view, extending over 150 meters around the vehicle, enabling it to see in all conditions, including at night and in the rain and fog. Now that it can see its surroundings, the vehicle must understand its location. Zoox drives within a predefined area, using a previously created geometric map, which shows a high-definition representation of the world. This, plus a semantic map, which shows things like speed limits, the location of traffic lights, and stop signs, is fed into the vehicle's powerful custom computer. The vehicle then aligns the sensor data to the map to localize itself and understand its exact location in the world. Understand its exact location in the world.
Oh, apologies here. Let's see if
Also understand, Zoox's perception system fuses the information from all of the sensors to understand what is happening around the vehicle. A combination of approaches, ranging from geometric techniques to the latest in machine learning, are used to detect and classify people, cars, trucks, cyclists, and other objects. Next, Zoox's prediction system processes this information to infer the future intentions of people and vehicles around it and determines what might happen next. For example, is this vehicle going to turn left? Is that pedestrian going to cross the road? Because there are many possible versions of the future, the vehicle accounts for multiple potential paths simultaneously. The planner is the decision maker of the system, taking the perception and prediction data and determining how to safely and comfortably drive. Because of the map, the vehicle knows which route to take to get from point A to point B. But how exactly? Should it change lanes? Should it slow down? Or should it accelerate? All of this information is fed into low-level controls, the software responsible for controlling the vehicle's acceleration, braking, and steering. This all happens within a fraction of a second as the vehicle is driving. And this is how Zoox is able to safely navigate through the world.
All right, hopefully that was enlightening. So this allows us to know where we are on the road very precisely. But once we know where we are, we need to be able to detect objects and changes in the world around us. And that we do through perception. So some of this you just heard, but I want to go into that in a little bit more detail. From a perception perspective, we use a combination and fusion of several different sensors, cameras, LiDARs, radars, and we're always on the look for kind of the next generation of sensor that's going to allow for us to deal with things that we have not been able to deal with. Things that we want to be able to see, everything from, pedestrians to cars to special attributes such as gestures, distractions. Hey, is this person looking down at their phone? Are they paying attention to the oncoming traffic? Little things like that as a driver, we just take for granted. These are things that we need to program our autonomous vehicle to be able to do and detect. So there's a lot of machine learning that goes into that and data sets that are fed in to our perception stack to allow for us to be able to detect all of the changes in objects that we need to in the world around us. And then we need to predict what these dynamic objects may do in the future. So if you think about this, if you're driving down the road and there's a car at a stop sign, right? You're making a determination as to, well, I'm driving this certain speed, so I expect that car is going to let me past, or hey, is the driver in that car actually looking at me? What direction maybe are their wheels pointed to indicate, are they going to make a left or a right turn? All of these different things come into play in terms of predicting what another vehicle and or person might do on the road. And then last but not least, we need to execute a safe plan based upon the combined data from perception and prediction. All of that comes down to, yes, having a plan, having a failover plan in case something were to go wrong, and then actually controlling the vehicle itself, acceleration, braking, steering. So all of that comes together to allow for us to drive safely on the road autonomously. So let's take a quick look here. This is actually one of our test vehicles that's driving around both in San Francisco and in Las Vegas. So you'll see a few examples of both, and just how our perception software identifies pedestrians, cars, trucks, and other things that are going on the road. And I'll kind of talk through this a little bit as we go through. All right, and don't worry, there is no sound with this, so you'll just be watching. So this, as you can see, some pedestrians just jaywalking across the road, and we're able to identify them and stop before we proceed. Again, coming here, you can see that we're identifying the traffic lights and, of course, all these pedestrians. Now, there's a lot of data to process very quickly. We're not only looking at the pedestrians, but what direction they're moving, where do we predict that they'll be in the future. You can see the green line here at the bottom. That is our intended path that we intend to go. Here is going to be an example of us navigating some construction work because roads are continuously changing. Construction is always happening. So you can actually see here as we fit through some very tight spaces to allow for us to go through. We recognize the stop sign there for the worker that was holding that. If they were holding that up, we would have stopped. Now, this was extremely tight space to fit through there, as you can see, but some people might have just stopped and waited. We were able to creep through. All right, this is some highway driving because everything's not just in the city area, and we're merging into some lanes of traffic on the highway. Now, here's what you see, some double parked vehicles. So vehicles that have just stopped in the middle of the road and they're not moving. So we have to be able to quickly detect that they are stopped, that there's no oncoming traffic, and make a decision that we're going to go ahead and go around them. Now, one of the challenges that we face as humans and autonomous vehicles face is weather conditions, right? So here we are driving in the rain and going around some double parked vehicles and passing by a pedestrian that's looking across the road. This is in Las Vegas, and as you can see, there's quite a lot of traffic and pedestrians in Las Vegas. So here's us merging into some multi-lane traffic. Again, everything that you're seeing here is 100% autonomous. Okay. So equally as important as the software is the hardware in which it runs. The vehicle size, sensor configuration, drivetrain, and many other features help simplify autonomous development and provide a comfortable and safe customer experience. A few of these features include a battery capable of lasting a full day on one charge, a design targeting 5-star safety for all passengers, and redundancy allowing the vehicle to safely complete its trip if one system fails. A symmetrical design that reduces the number of stations required to assemble the vehicle. The advantages of this will really be seen as we continue to scale. Four-wheel steering. That helps us get in and out of tight spaces. Our bidirectionality can also help reduce the path planning challenge. So you can see here, there's no real front or back here. Both sides are symmetrical. And the wheels themselves can actually, all turn so that, we can have very good maneuverability in those tight spaces. We're also designing our vehicle to be long lasting. The intention here is for this to be a mobility as a service. So this is a useful life greater than 400,000 miles. The integration of both our software and purpose-built hardware will result in a product built for riders, both inside and out. All right. And that last video you saw there, that was actually shot on a closed area within in San Francisco, for those of you who might be wondering. All right. So, as a student, how might you get more involved in things like robotics and automation? If you heard my intro, one of the things that actually started me down this path was my work and ability to get involved with the first robotics program, which was a K-12 non-profit organization focused on inspiring students to pursue careers under higher education in STEM using robotics as the medium. So I actually did that in high school myself. Before doing that, I kind of had a sense that I wanted to do something in engineering before that, but others that I went to school with did not. And once they got a part of this program, they got hooked. Hooked not just on engineering and STEM and working with robots, but I think about this from the standpoint of, hey, maybe you're not going to be a roboticist. Maybe you're not going to be an engineer. Hey, I hope you are, but maybe you're not. Hey, there's a ton of people that need to work in these industries, as I highlighted earlier on, that need to be able to work very closely with engineers and with people that are very highly technical. And getting involved in this program, one of the first says is it's more than just robots, because there's so many other things that you can learn from a personal perspective, giving back to society, volunteerism, things of that nature that come along with being parts of these programs. So I do encourage you to look that up when you have the time. This is a global program, and you can take a look at what opportunities might be available. Similarly, there's many others, but these are just a few I intended to highlight. Vex Robotics, they're a company focused on developing and delivering K-12 educational robotics solutions. And they've partnered with the Robotics Education and Competition Foundation to put on competitive robotics events. And then last but not least, Zoox. Again, not just Zoox, but many other technology companies out there. If you're looking for an internship or career in robotics or automation, please take the time and visit the website. With that said, thank you all once again. I hope that this has inspired you to continue along your path or to start your path along STEM and STEAM. And at this time, I'll go ahead and open it up for questions. I think we have about 10 minutes for questions. And apologies, I can't really hear the person talking, Dr. Owen Roberts.
That they've been now, he further continued to talk about the idea
Was the sensors that were built with the microchip to be able to navigate the terrain for the vehicles that they're building. This is an exciting future technology that we're seeing already. And so while you're thinking about questions you might have for him, I just wanted to break that down to understand the big picture as to what we actually presented. So it's important. So make certain you have your questions in a moment to ask him. Any question related to the technology, present and future. And as he mentioned, he showed a demonstration of vehicles that are actually being tested in places like Las Vegas, San Francisco, New York, Arizona. And these are vehicles that do not have a human being in it. And they're doing this to actually help with one, climate condition, two, relating to safety, because the statistics are very clear that the vehicle that is driven by the computer, the robot in the computer, is safer than, because of our response time. It's better, and it's all involved with mathematics and with physics. All those are things that engineering. So I hope it means to get a picture for what he was actually sharing.
Okay, my question would be using
Can you bring it back? Is there is he hearing us?
You can type it in the chat.
No, I'm hearing an echo, and you guys are in and out. Apologies.
There's also technological.
No, so I did not hear your question. I just hear apologies. I just hear an echo here on Zoom. So if you wouldn't mind, maybe in chat, and I can respond verbally here. So I did see one question in the chat, so I'll go ahead and respond to that if that's fine. There was a question that was when will Zoox be launched? So the answer to that is the exact date is not public. However, we and several other autonomous vehicle companies are actively testing in several cities, as was mentioned, San Francisco and Las Vegas being two of them. You'll definitely hear more about this over the next few years, so please stay tuned.
Are you hearing me now?
Yes, I am hearing you.
Yep. Nod your head.
Yes.
Oh,
I'm here.
wonderful.
Can you hear me?
All right. Her question was, as a result of the fact that with this automated technology, what would happen? What safeguards are in place if somebody decided to hack the technology? What safeguards are in place? Give us your clear answer as best as you know.
Sure. Well, I'll have to give you obviously the answer that I can give you at this point, but we do take safety and security very seriously, right? As with any vehicle that's on the road or any other type of technology, that we're sending, rockets to space and satellites. All of these different technologies have very, important cybersecurity concerns. So we do have a security team that works very cross-functionally across all of Zoox to ensure that as we're designing our hardware, as we're writing our software, and as we're putting all the different pieces together, that security and safety are the two kind of paramount things in our mind as we're developing this product. So yes, obviously these are concerns that we will continue to address before we actually get to market.
Thank you. Very good question. So he says there's cybersecurity infrastructure in place to actually address it. Just like when you're talking about launch motor rockets or whatever it is, all of that is involved with technology. And so security is in place to ensure that things can be caught early and prevented. Very good. Any other questions?
Okay. Tesla has their FSD beta. I was wondering if you guys share statistics or data between Zoox and Tesla, or is it entirely individual?
So I can't speak directly to what we're doing with other companies. However, something that is important to note is that the data that you collect in large part is due to not only the sensors that you're using, but also the sensor configuration that you're using. And then of course, all the code and everything that goes on behind that. So while there would be potentially some advantage to sharing data between companies, not just Tesla, but you've got Waymo and Cruise and many other companies that are doing autonomous vehicles. The reality is that the data that you collect on your vehicles, if you remember the video that I showed with our test vehicles, those test vehicles have the same sensor setup and the same sensors that the vehicle that you saw at the end, which is the fully autonomous L5 vehicle, is going to have. So we can use that data basically one-to-one between our test vehicles and that vehicle. Between, as you were saying, say a Tesla and a Zoox vehicle, our sensor configurations and the sensors that we use are different enough that while there might be some use, not necessarily as much as you might think.
Thanks, Jeremy. Yeah. Any other question? We're going to invite the persons who are actually asking questions come to the front so you can ask your question. We have a few more questions, Jeremy. Hold on there for a while. I know you're at work.
That's okay.
So, advantage of I remember hearing was quite they would say that workshop like Semiconductor. Actually
Turn off.
So I don't know the advantages of this kind of technology.
Apologies, I'm having trouble hearing.
Don't know if you can answer this question.
Well, I couldn't hear it, so if you wouldn't mind repeating it.
You didn't hear the question?
No.
So they want to know, the question relates to what is the advantage of this technology to the military? Because of course there have been information being publicized, especially with the war in the Ukraine, relating to the fact that these military equipment are actually built with these kind of technology. Can you speak to that in any degree about that kind of technology in the military?
Well, first of all, I'll say that Zoox, our focus we remain focused on delivering mobility as a service. So a ride-sharing service using our autonomous vehicle, and that's what we'll continue to focus on. The uses for technology, in general speaking, right, both have can be used for good, can be used for evil, can be used to benefit society, can be used to the detriment of society. So, I would just say that as everyone here, you heard me talk through my presentation about the why, and the why being just as important, if not more important than the what. Please always keep that in mind as you go through developing and innovating.
Thanks so much. Are there any other questions? Yes.
I would like to know what are the new technology car control. I would like to know what are the new technology car controlled by, and what are the measures if it failed.
Okay.
I would like to know what are the new technology car methods and what happened if it failed.
Okay. Hopefully I understood your question. So
did you hear that question, Jeremy?
Yeah, I heard the question, and you can let me know if I misunderstood it. Asking about what are the new technologies within cars and what happens if they fail.
Yes.
So, first of all, with any type of autonomous vehicle, or whether it be the one that Zoox is building and designing that has no driver itself, or driver assisted features, which you're seeing in a lot of vehicles today, right? Everything from, people don't think about it anymore when they hit cruise control, right, on their vehicle, and it follows the car behind it. So all of this is enabled by various sensors, right? Everything from radar sensors, cameras in some cases. The newest ones are LiDAR, and that's where you're sending out laser pulses and determining how, the distance that the vehicle is and what that vehicle may be. So all of that's the technology. And then of course, on the back end of that, there's a lot of computing and software using machine learning and things of that nature to enable the vehicles to detect what objects are out there and what changes are being made in the environment. Now, as far as failures, all of the vehicles that we design and that you see on the road in general have redundancies, and they have a certain level of assurance that's put in from a documentation perspective, from a review perspective, to ensure that, hey, number one, this has very high reliability, and then two, if there is a failure, we have mechanisms in place, redundancy of hardware, for example, in order to make sure that we can safely come to a stop if there's a problem.
We have one last question, Jeremy. One last question. However, we have two more? Oh, we have some more? Okay, well, one moment. Right. How many of us like technology? All right, computers, phones, those things. Everything we're talking about relates to what you're using. So let's take the next question.
My question is,
speak loud so they can hear, but okay.
My question is, what if when an accident happened and someone's inside the car, what procedure will you use?
Did you hear that?
Yes, I did. Yes, I did. So first of all, if there's ever an accident that occurs with the vehicle, the exact procedures are obviously still being developed. Our vehicle is not currently on public roads. However, there will be mechanisms for communicating with authorities in order to make sure that they are aware if something were to happen. Also communicating back to the company itself and allowing for us to communicate to the individuals inside the vehicle. A lot of those technologies actually exist today in other vehicles. We will also be doing something similar to ensure the safety of all the passengers involved. And of course, if you saw in my presentation earlier, the actual design of the vehicle itself is such that all the passengers sitting inside will have airbags and things of that nature to ensure that they're safe in the event of an accident.
So that's important because indeed they're collecting data on these kind of things when they happen, so they can actually address it and correct it for the future. Last question I believe we have here, Mrs. Smith. Okay.
So my question is, so
take off the mic and
like how you have
talk to the audience, but also
my question is like how you have Tesla driving by itself, will you have planes flying automatically?
You heard the question. For example, what Tesla has done, are that technology available for airplanes as well?
Oh, okay. In actuality, airplanes probably have equally, if not more advanced technology already. Many people don't know this. Now, I'm not in the aviation industry, but autopilot has actually gotten pretty good nowadays, in the sense that, yes, we do have to have very skilled pilots, but the planes in many cases can fly themselves.
So the technology extends itself to other automation. For example, you know that sometimes if you're in an airplane, it is possible for the pilot to give control over to the robotic system in the plane, whereby the pilot, he or she, basically doesn't control it. That is possible. And right now, that drones, for example, even though you can control them from outside, but drones are actually a part of that robotic system. And by the way, I just got a toy drone last week, and I'm looking forward to flying it. With that being said, I think, Jeremy, we appreciate the presentation and your answer to the question. Thank you very much, but I turn it over to Mrs. Smith so she can do this officially. Thank you.
Thank you.
All right. Thank you very much, Dr. Roberts, and thank you very much, Mr. Jeremy Roberts. Am I being heard clearly?
Yes.
Students have many more questions, Jeremy, but we are out of time, and we have been struggling a bit to ensure that we fit into the right groove and so, but you have brought many things to light this morning. There will be someone to do the vote of thanks a little later. I know you are at work and you have taken time out of that particular work day to be with us, and we really want to appreciate you at this time. We want to segue into the awards, so you may be able to see a few of our students who are getting awards. But just before we move into the awards, is it our science choir, led by Miss Thomas, and on the keyboard, who do we have on the keyboard? We have Joel on keyboard, and we have on the drums, John Benet. So they will render an item of music at this time.
I have a maker. He formed my heart before even time began. My life was in his hands. He knows my name. He knows my every thought. He sees each step that falls and hears me when I call. I have calls me his own. He'll never leave me, no matter where I go. He knows my name. He knows my every thought. He sees each tear that falls and hears me when I call. He knows my name. He knows my every thought. He sees each tear that falls and hears me when I call. He knows your name. He knows your every thought. He sees each tear that falls and hears you when I call. And he hears you when you call.
Okay. At this time, I'm going to invite to the podium Miss Thomas and Miss Dennis, who will be announcing the names of the awardees. Thank you.
Our Home and School Association president is also with us, Mrs. Hilary Wright. Can you just join us to congratulate those students who will be receiving awards? Thank you.
And now, the time that we have all been waiting for, the time to award our science students for their excellent academic achievement. The subjects to be awarded are general biology, physics, chemistry, information technology, agricultural science, human and social biology, integrated science, mathematics, physical education, food, nutrition and health, building technology, and technical drawing. The students who will be receiving awards have been received awards today have demonstrated excellence in these subject areas. When we call your names, you will come to the podium and receive your award. We will begin with second form. And I will ask that everyone hold your applause until we finish each form group. Please hold your applause until we finish each form group. From second form, we have Rowena Banton, Nathan Clark, Alicia Kramer, Jetanique Gordon, Kyle Grant. DeMarco Hall. Nicholas Henry. Angelique Nickel. Ashanti Reed. Chelsea Senior. Dejon Wilson. Kaylee Wright. Najwa Winter. I invite a round of applause for the second form awardees.
And from third form, we have Sarah Earl. Sarah. Sarah. All right. So that was Sarah Earl. Anicia Edwards. Shakira Gardner. Roger Miller. Joshua Swaby. Joel Wright. All right, we now invite the round of applause for the students. Applause for the students.
And now for my beloved fourth form students. Dylan Beadle. Sarah Beth Burton. Daquan Dixon. Samuel Narayana. Joseph Onowere. Brianna Sharp, who is unavoidably absent. Joshe Smith. Romario Tabanor. Britannia Walker. I invite a round of applause for the Form 4 students.
Ms. Thomas spoke about her beloved fourth form, the cream of the crop. Yeah, like, yeah, the topping, right. That nice little piece of cherry, yeah. All right, Danica Henry. Dominique Reed. Lorian Salke. Romina Tamanor. Jonathan Wright. Let's give them all a round of applause again.
Okay, thank you, Miss Dennis and Miss Thomas for the presentation of the awardees. I'm going to invite for all the awardees a grand round of applause. And at this time, I'm going to issue a challenge to those of you sitting in the audience who, if you had worked a little bit harder, you could have been sitting in the front row. So I'm issuing a challenge to someone out there who would like to be sitting here next year. And if you know you will be sitting here next year, I'm going to invite you to give yourself a round of applause now. Those of you who would like to be sitting in the front row next year, give yourself a round of applause. Please, I want you to aim high. I want you to believe in yourself. So next year, this year we had 34 awardees sitting right here. And next year, I want the awards to be doubled. So I'm issuing that challenge. First form, second form, right up to fourth form. I want to see more students being awarded on this special occasion. Now at this time, we are going to be favored with a special item from our fourth form science group. They will be doing a choral speech presentation for us. Fourth formers, come forward. And after that, we will be favored with a special presentation from Samuel.
Ziegler, Bennett, and Pope. Be aware. Be aware. Now we see through a glass darkly, and as unclear as the view may be, we know with much certainty that motivation is the spark that lights the fire of knowledge, that fuels the engine of accomplishment, and maximizes the momentum of growth.
And yet, we know that self-discipline is the virtue we use to manage ourselves and the different parts of our lives. It involves controlling our temper, our wishes, our appetites, our egos, and our mouths.
For vice is a monster of so frightful mien, as to be hated needs but to be seen, yet seen too oft, familiar with her face. We first endure, pity, then embrace.
Only with eyes of faith can we see beyond the darkened glass, the path that God has cleared for our tiny, willing feet.
Beautiful, beautiful. Indeed, that was inspired by our dear principal, Mrs. Smith, who has been giving us those gems to memorize. And it was put together by our two wonderful English teachers, Mrs. Morgan, as well as Mrs. Spear. Thank you very much. And so Samuel will come forward with his special presentation, and it is going to be focused specifically on our theme for today, glass, more than meets the eye, and he will be delving somewhat into the science of glass, the physics and chemistry of glass. So Samuel will now proceed with his presentation. Thank you.
Good morning, everyone. Today, I'll be presenting on the chemistry of glass. I'll be looking at what glass is, its chemistry, that is to say its makeup, how it is made, and what it is used for. Glass is a solid-like and transparent or translucent material. It is hard and brittle. It is a good electrical insulator. It is amorphous.
You have another mic?
Stretch. Ask everybody to just stand and stretch while we work this out. All right, audience, we are moving very quickly to the end of the program. But just before we continue that feature with Samuel leading out, I want to give you just a 5-minute stretch. Now you have to cooperate. You've been sitting for a very long time. So you're just going to stand, stretch, and sit again. So let's stand. Come on. Let's stand. All right, just a little stretch. All right, you may sit. Okay. All right, so compose yourselves once again. We are ready to move towards the final stretch of this program. So let me invite Samuel to come again at this point. So let's give him our full attention. Give him a round of applause. Cheer him on as he comes.
Today I'll be presenting on the chemistry of glass. Glass is a solid-like and transparent material. Oh.
So what I'm gonna do, because the mic will project for the persons online, so they're hearing clearly. But since someone will project that well, I'll just say what he said for your sake.
Glass is a solid-like and transparent. Glass is a solid-like or transparent or translucent and transparent.
Glass is a solid-like and transparent, translucent material.
It is hard and brittle.
It is hard and brittle.
It is a good electrical insulator.
It is a good electrical insulator.
It can absorb, transmit, and reflect light.
It can
absorb,
transmit and reflect light.
Glass has no specific melting temperature.
Glass has no specific melting temperature.
Softens over a temperature range.
Softens over a temperature range.
It is not an organic substance.
It is an organic substance, which means that it's something that it can be broken down, something that is made up of something living or was living.
This it's not.
Or C8.
It's not.
It's not. That means it's not. That's it.
It's typically made of three substances: formers, fluxes, and stabilizers.
It's made up of three substances: formers, fluxes, and stabilizers.
Formers form the largest percentage of the mixture.
Formers form the largest percentage of the mixture.
Fluxes lower the temperature at which formers will melt.
Fluxes lower the temperature at which the formers will melt.
And stabilizers make the glass strong and water resistant.
And stabilizers make the glass strong and water resistant.
Okay, thank you, Samuel, and thank you, Miss Dennis, for assisting. Now we have come to the close of our program, and of course, to give the vote of thanks, I'm going to invite one of our awardees, Dominique Reed, who will come forward to move the vote of thanks for us. Dominique Reed.
A warm and graceful good morning to you all. It gives me an immense pleasure to deliver the vote of thanks for this event to all the distinguished guests assembled here. I would like to thank the chairman of the board, Dr. Vivian Quarry, Dr. Owen Roberts, patron of the Owen Roberts Lecture Series, Dr. Jeremy Roberts for the special presentation about Zooks and the semiconductors. We really enjoyed hearing about the potential present and future of cars. Ms. Carol Baker from the Ministry of Education, Mrs. Archie Simmet, principal of the Victor Dixon High School, Jonathan and Joel Wright for the special piece, Samuel Nariana for the special feature, the fourth form group for the choral speech, the special science choir, Romina Tabanor for the opening prayer, Andrew Garden for the scripture reading, Britannia Walker and Joshua Smith for the special song, Rave Edwards for the opening hymn, all the teachers of Victor Dixon Science Department, and last but not least, our beloved audience for making this function as a grand success. Thank you.
Thank you, Dominique. Now we are going to focus our attention to the screen where we will be allowed to view some product samples from Victor Dixon High School, brilliant students who have done well. So
Greetings from
focus on the screen's presentation.
the Victor Dixon High School Board of Governors, administration, staff, and students. The current coronavirus pandemic has presented many challenges for the education system. But one institution continues to meet and surpass expectations: the Victor Dixon High School. Victor Dixon High is a values-based Seventh-day Adventist Christian institution which prizes work, integrity, and dedication. She has an enviable record of academic achievement and student success, as the school continues to see approximately 80% of its graduates achieving 5 or more CSEC passes, many earning 9, 10, 11, and even 12 CXC passes, way above the national average. This qualifies them to enter any tertiary institution of their choice. Some of our recent outstanding achievers include Pastor Conroy Shakes, Patrick Fung, architect, Greetings from the Victor Dixon High School Board of Governors, administration, staff, and students. The current coronavirus pandemic has presented many challenges for the education system. But one institution continues to meet and surpass expectations: the Victor Dixon High School. Victor Dixon High is a values-based Seventh-day Adventist Christian institution which prizes work, integrity, and dedication. She has an enviable record of academic achievement and student success, as the school continues to see approximately 80% of its graduates achieving 5 or more CSEC passes, many earning 9, 10, 11, and even 12 CXC passes, way above the national average. This qualifies them to enter any tertiary institution of their choice. Some of our recent outstanding achievers include Pastor Conroy Shiggs, Patrick Fung, architect, Janique Smith, food scientist, Olivia Valentine, medical doctor in training, Glenella Samuels, medical doctor in training too, Michael Harvey Jr., computer information system specialist, Jalene Smith, medical technologist, final year finance student, Chad Koch, who was the first student to win the Jamaica Stock Exchange Market Research Competition, Matthew Brown, electronics and engineering student. Some of our latest performing graduates are Ariel Roach, Elizabeth Burton, Aldania Codlin, Jeremiah Dennis, Nia Adonis, Radikia Henry, Jaden Forbes, Gamaliel Newman. These and others continues to be beacons of hope and inspiration. If you are looking for an
Okay, now we are going to continue sitting while our awardees will stand, and they are going to, at the playing of the recessional music, they are going to lead out. Please stand. Okay, thank you very much. Final round of applause for the awardees. Thank you very much. We have come to the end of our program. And so at this time, you were thanked, those who were watching us live on YouTube, those on Zoom, those who were watching us live on YouTube, those on Zoom, and those of you are very dearest, those who are face-to-face with us right here in the Victor Dixon High School auditorium. We are going to, at this time, you're going to be moving back to your classrooms, and we are going to resume the third and fourth session of the day. We're going to resume the third and fourth session. Lunch, it's not lunchtime yet, and lunch is not ready. So we're going to the third and fourth session. All right, thank you very much. First formers, these